Hi guys, today we're going to do the Hydrate Lab together. So the purpose of this Hydrate Lab is that we are going to be given a hydrate, which is copper 2 sulfate, and it contains water. And our job is to find the formula of that hydrate. So copper 2 sulfate is CuSO4. We know it's a hydrate, so we know that it has some amount of water in it. So this portion by itself, just the copper sulfate without any water, we would call the anhydrous. Anhydrous means it's not hydrated, it doesn't have water. But with the water, the whole thing would be called a hydrate. So a hydrate is an ionic substance that has water trapped in its crystal. So basically, the goal of this lab is to determine what X is. It could be 2, it could be 4, it could be 5, it could be any number here. And so we're trying to find the formula of the hydrate by finding that X. Well, that X is the ratio of the moles of water to the moles of the anhydrous. It's how many moles of water for every mole of anhydrous. So to find the X, we need to take the moles of water divided by the moles of anhydrous. So how do we do that? Well, we take some of our hydrate, which is the copper 2 sulfate hydrate. This is what it looks like. It's a beautiful blue color. We're going to mass it. Then we're going to heat it up so that we drive off the water. Now remember, this is an ionic substance, so nothing will happen to the copper sulfate itself if you heat it. It's not going to melt, it's not going to vaporize, it's not going to do any chemical reaction. All what's going to happen if we heat it is we're going to drive off the water. So after heating it, what we're going to be left with is the anhydrous, the dry CuSO4. So then we're going to mass that, and if we have the grams of the anhydrous, then we can change it to moles so that we can plug it here. Now to figure out the moles of the water, well, we have the mass of the whole thing with the water. We also have the mass of it without the water. So if you subtract the 2, that's going to give us the mass of the water, and we can go from mass to moles, and we take the moles of the water, divide the moles of anhydrous. So let's read the directions together. It says obtain a dry, clean evaporating dish and mass it. So this is what an evaporating dish looks like. We're going to go ahead and mass that. So we get our balance. Close here. Make sure that we hit 0. And I'm going to put it in here. And we're going to record the mass. Okay? Let's read step 2. So step 2 says, using a spatula, put anywhere between 1 to 2 grams of the hydrate into the evaporating dish and record its mass. So we're going to take our evaporating dish again, and we're going to add some of that copper sulfate. Okay. And then step 3 says place the evaporating dish over a Bunsen burner, heat the evaporating dish for about 5 minutes. Then we're going to allow it to cool for 5 minutes and mass the evaporating dish with the resulting anhydrous substance. So here I have a ring stand with a ring clamp. On top of that, I'm going to put a clay triangle so that I can put my hydrate in the evaporating dish, and I'm going to heat it up with a Bunsen burner flame. And when we heat it up, we should drive off all the water. So I'm going to go ahead and light my Bunsen burner. And you can adjust your flame. You want to kind of heat it kind of vigorously, and we need to heat it for about 5 minutes or so. And go ahead and kind of break up some of these clumps. And the cool thing about copper sulfate is that when it's in the anhydrous form, when it doesn't have any water, it's actually kind of a whitish, grayish color. when it's hydrated, it turns blue. So I don't know if you can see this, but the parts that are starting to dry here are turning to a lighter color. So I'm going to continue to heat this for 5 minutes, and then I'm going to let it cool for another 5 minutes, and then we're going to mass it together. All right, so it has been heating for 5 minutes, and then I let it cool for another 5 minutes. And just so you can compare here, here's the hydrated blue color, and here's the anhydrous. So to check if it's cool enough or not, you put the back of your hand close to it, and if you don't feel very much heat, then you can get a little closer and a little bit closer. And you can only mass it when it's cool to the touch. So I'm going to go ahead and mass it now. So go ahead and record. And if we were in class and limited on time, we would just be done with the lab. But if you were doing this in college, you would actually keep heating it and cooling it until you get a consistent mass to make sure that you've driven off all the water. So what I'm going to do is I'm going to go ahead and heat it again for 5 minutes, let it cool for 5 minutes, and then we're going to remass it. So I've heated it a second time, let it cool, and I'm going to go ahead and mass it again. And if the masses are the same, then we're going to stop. If the masses are different, we're going to remass it. So it's a little bit different. So I'm going to go ahead and reheat it a third time, and then mass it for a third time. Okay, I've reheated it a third time. Check if it's cool enough to touch. Yep, it's good. So we'll go ahead and remass it. I believe that's very close, if not the same as, I think it's very close to the previous mass, so that's pretty good. So we're going to clean up and do our lab calculations. I do want to show you that when you are cleaning this up, it's pretty cool. If you add a drop of water to it, it's going to get rehydrated, and it's going to turn back to a blue color. Isn't that cool? All right, so if you do the calculations here, those will kind of lead you to number 10, which is the ratio of the moles of water to moles of anhydrous, which is your X, so that you can get the formula of the hydrate. Have a wonderful day, guys.